We're going to continue with simplifying radicals. This time we're going to work on doing some multiplication of radicals. So you go down to the bottom page. It says combine terms by multiplying coefficients and radicands separately. That's a key word. What they're saying is when you have radical with a coefficient, like on these two examples, there's a 5 is a coefficient here. The coefficient on the second is a 1. What's outside the radical, the 5 and the 1, and what's inside the radical, the 3 and the 5, they stay there. So if they're outside, they stay outside. If they're inside, they stay inside. So when you're multiplying these, the 5 times the 1 is going to be 5. They're both outside the radical. Again, there's a 1 in front of this. And what's inside the radical stays inside. Well, the 3 and the 5. 3 times 5 is 15. And then at that point, you look, all right, can I simplify this 15? Well, again, I don't think there's any perfect squares in there. 9, 4, 16, no. So that's basically the answer for that first example. For the second one, again, what's outside stays outside, the 2 and the 4, multiply those. What's inside stays inside, that's 6 and a 10. So 2 times 4 would be 8. 6 times 10 is 60. Now I think, okay, can I simplify this 60 at all? Are there any perfect squares in 60? Well, I think I can try this. 8 and 4 times 15. 4 times 15 is 60. And continue on, square root of 4, square root of 15. Square root of 4 now becomes 2, and again, I write it outside the radical. And then now this square root of 4 has become a 2 outside, and I can combine it with the 8. 16, square root of 15. So you can multiply what's outside and multiply what's inside, and then simplify. Another method is on the page, create a perfect square by factoring first, and then combining radicands. So what do I mean by that? Bottom page, if I look at the first example, if I multiply the 8 times the 18, I'm going to get a number that I may not be able to work with. So I can break these down into perfect squares as such. So the 6 stays. This is 4 times 2. And we can jump ahead a little bit here. I'll just write square root of 4, square root of 2, just to save some room. And then for the second one, square root of 18, I know that's going to be 9 times 2. So square root of 9, perfect square, square root of 2. 2 times 9 is 18. 2 times 4 is 8. So again, these are still inside radicals, right? So what's in is in, what's out is out. The 6 is still out. But now I can simplify this, I can simplify that. So this is going to be 6 times 2. I'll bring this through, this is 3, so I'll bring this over here. And I have square root of 2 times square root of 2. Well, if I continue this, I'll have 36 on the outside. And 2 times 2 is, well, it's 4. Square root of 4 is 2. 72 is the answer. Okay, let's try one over here. I'm going to simplify these first, because 20 times 45 is a big number, and in fact, if you see it, it works. Let me show you, this way with this one. If I just multiply 3 times 2 is 6, and 20 times 45 I think is 900. Now that may not be obvious to you, but that's going to be 30. 6 times 30, this is 180. But you may not know that perfect square, and that makes it difficult to do it that way. So by factoring first, it might be easy. I just realized I made a mistake going through this one while factoring it, so I'll try again. Again, if you multiply what's inside and what's outside, you get the 6 and 900, and 900 becomes 30. 30 times 6 is 180. You may not get such nice answers, and that's only if you consider that nice. Sometimes they're really ugly. So you must factor these first. So for instance, we can take, it'd be the 3, and I know 4 times 5 is the 20, and 4 being a perfect square. And then the 2, and this can be 9 times 5, again, 9 being the perfect square again. Square root of 9, square root of 5. And now I have to take all the numbers that aren't radicals. This becomes a 3, a 2, with this 3 and 2, so I have basically 3, 2, 3, 2, all multiplied. Almost left is square root of 5, square root of 5. This is 6 times 6, which is 36. 5 times 5 inside the radical becomes 25 inside the radical. That becomes a 5. Multiply that, that's 180. So you get the same answer. It's a little more work, but if you don't see a nice number here, you're going to end up doing this anyway. Okay, I'll try one more for you, and I'll let you guys work. If you go to the back, let's try one at the bottom here. Let's try like number 22. 32, and 5 times square root of 32, and 4 times square root of 54. I know 16 goes into 32, and 9 times 6, 54, so it's 5 times square root of 16, square root of 2, 4, square root of 9, square root of 6. Get 9 times 6, 54, 2 times 16, 32. Perfect squares. So 5 and 4, I'll put them out here first. This is another 4, and this becomes a 3. And then all that's left is the 2 and the 6. Square root of 2, square root of 6. Wow, let's see, 20 times 12, 240, I think. Square root of 12. Well, guess what? You're not done. I think 4 and 3 will work with this, so it's going to be 240. Square root of 4, square root of 3. That, of course, is 2. Better go over here. I can fit here. 240 times 2, square roots of 3. And 2 times 240 is 480 square roots of 3. And now you're done. And that's how you do it. All right, you have the rest of the page to do.